So we are now familiar with a scan. Again, it makes my job easy. I don't need to know anything about the molecule. I just put the substance into the machine. I close the door. I give it a window. I tell it to scan in this window. And this is something that I could see on the computer screen. I now know that molecules have particular favorites in the buffet line. Those favorites show up to me in the form of the peaks that I'm shown on the computer screen. However, they always have one particular favorite, and it is this favorite that I want to give them. And we call that the lambda max. So the purpose of the scanning is to allow me to determine what the lambda max is. All right, so let me go over to my notebook and let me just write in that reminder. Scanning, the whole purpose of that is to find the lambda max. That's the only reason that I do it. I don't do anything else in the scanning feature. And I'm going to repeat that. I do not do anything else in the scanning feature. That's it. That's all that it should be used for. If my job is to report quantitative data, I do not scan at all. The only purpose of the scan is for me to find the lambda max. And when I find the lambda max, then I can do quantitative data work. But only until I find this number can I then quantify. Then I can go through and report numbers and do measurements and do my analysis on it. But I do not do it in the scanning feature. The only purpose of the scanning feature is to find the lambda max. That is it. And I keep repeating this over and over because no matter who you are, if this is your first time looking at a UV vis instrument, this is the number one common problem that people have. They think that because they bring a sample into a lab that they can scan that, and they can scan another sample and scan another sample and scan some standards that they have made, and then use these scans to do data work, and they can't. Doesn't work that way. Scanning is only used to find the lambda max, which is the number that you should run everything at when you make it. Okay, so after I scan, that's kind of step number one. Step number two, I then go into the go-to feature. And if it's not listed as a go-to, sometimes it's called the fixed application. So, go-to or fixed, it's one or the other. On our thermo units, I believe, use the word fixed. So the point of the fixed application is it will want you to type in the lambda max. And it will analyze all of your samples at that lambda max. It, of course, does not do a scan. It only looks at one wavelength, and that is it. And the reason that we do the analysis using the fixed is to eliminate that variable. Because here's the deal. If I'm trying to measure caffeine, I have a series of caffeine standards to make. I can scan those, each and every one of them. And I guarantee you that my scan will give me a different wavelength on each one. They'll be close, but they'll be different. I take my samples that I want to analyze. I scan those. I guarantee you the lambda maxes will be slightly different. They might be decimals off, but they'll be different. And we don't like that difference. We want everything to stay consistent. And that is the entire point of the fixed region. It keeps everything consistent for us. And it eliminates variables that can happen in my data analysis. So everything is staying consistent. We are comparing apples to apples. I type in one number. That's it. One number out of the entire electromagnetic spectrum in the UV and visible portion. And the machine will only give me data based on that one wavelength. That is it. That's all. So it eliminates the variables. It makes my data processing much better. So what happens then is that, let's say that we have a spectrum and it goes from 200 to 400, and let's say that we get a spectrum that looks like this. What happens is that we've got some different lambdas here, and those different lambdas, this is the lambda max from my scan. So this would be my scan. I know that that lambda max is going to be right here. So let's say that this is 337. All right, in the go-to feature, or the fixed feature, when I switch it over to this method, the machine will want to know that number. What number do you want me to use? I'm not going to scan. You're going to tell me the number that I should be measuring it. So I would type in 337 for this particular compound. It's different for all of them. And what happens is that it completely ignores everything else in the spectrum. It just pretends like all of that mess is not even there. That's it. And it only looks for this one number, and that's all that it does. And this is my fixed application. So everything that I have made, all the samples that I have made, I bring to the instrument. I tell the instrument, I want you to analyze all of these at this time 337 nanometers. And the instrument says, okay, I'll do it. And then it begins to process the samples, and it gives me the data from the samples. Now, what kind of data does it give? Well, we've not really talked about that yet. We've only talked about the point of the lambda and the wavelengths. So in the upcoming videos, that is what we're going to focus on. What kind of data are we reporting? What is the machine telling me? What does that number really mean? That's what we're after. So that's the story and the difference between fixed and the scan. So in a laboratory practical, you probably are going to be given a compound, and you're probably going to be told to scan the sample first, find the lambda max and write it down. Then you're going to be told to go into the fixed portion, type in the lambda max that you found from the scan, and begin to do your analysis with it. That is the proper steps. Not only for their program, not only for competition related stuff, but also in industry. That's how it's done. Okay, so the video is going to stop here, and in the next video we'll talk about what kind of numbers are popping out of the machine. Now that we know what it's looking for, what kind of data is it telling me? And we need to go back to how the machine is made in order to determine that. So stay tuned. There's so much more to come.